Alright, the concept we're going to be talking about is synthetic division. Synthetic division is an alternative to long division. This little section here at the beginning, long division is not a requirement for Algebra 2, so I'm not really going to waste time talking about it. Long division is reserved when you guys are dividing polynomials and your divisor, the thing you're dividing by, has a power with it. But the types of division we're really going to be focusing on is this kind of division where the divisor is a linear function, so it's a binomial with a power of 1 essentially is the degree. But again, I'm not really going to talk about long division. We're going to focus on synthetic division, which is a, in my opinion, better way to do the division because it's less complicated. Synthetic division is just multiplication and addition. You guys can multiply, right? You guys can add, right? That's really all that synthetic division is. The only complication that comes with synthetic division is all the details you have to check before you can actually get started. There are a lot of things you have to check. There's a checklist you have to kind of go through before you can actually start the synthetic division. And so that's what I'm going to be describing here in the setup. I'm going to describe each step that you need to go through. And then the actual process of synthetic division is spelled out for you here, and there's an illustrated example at the bottom. So let's start with A. Step A, when you guys see your problem, this is the example right here. So you're dividing this polynomial, the dividend, by this polynomial, the divisor. The first thing you want to do is check that the dividend is in standard form. Check that the dividend is in standard form. If it's not in standard form, you should put it in standard form. As a reminder, standard form means that the biggest exponent, the term with the biggest exponent should be first, and then everything decreases in order behind it, right? So in this one, the highest exponent was the 4, so that was first, and then it should go 3, 2, 1, nothing. So I see that I have x to the 4, x to the 3, x to the 2. Do I have x to the 1 here? But do I have a number without a variable? Yes. So in addition to checking that the dividend is in standard form, you want to look for missing terms. This is another thing you want to do at this step. Because there's something special we have to do when we're missing something. Okay? So standard form, the traditional standard form needs to have the highest exponent first, and then it must contain every exponent below that. So if it's missing one of the powers, make sure you take note of what's missing. Okay? Step B. Step B is to solve the divisor for x. Solve the divisor for x. The divisor is what you're dividing by, so you're going to find that here. It's going to be the linear polynomial or the binomial. So when you set this equal to 0, because you're solving for x, you set equal to 0, you're essentially just going to get the number to be opposite what was inside of the parentheses, and you're going to write off to the side. You're going to establish your work area by wherever you put that number. So your setup's going to look like this. You're going to put it somewhere to the left, and then everything's going to go to the right of that. So you just set it up by writing that number that you got off to the side. Step C is going to be this list right here. This list of numbers. You're going to write the coefficients of the dividend. Right? The coefficients of the dividend. Parentheses, use a 0 for what's missing. That's why it was important in step 1 to take note of what's missing, because if something is missing, if a piece of the standard form is missing, you can't just ignore that. You have to put a 0 in its place, so it's like a placeholder. So for example, in this one, we took note that the x by itself was missing. So the coefficient of x to the 4 was a 1, so I wrote 1. The coefficient of x cubed was -3. The coefficient of x squared was -11. Because I didn't have x to the 1, I wrote a 0 as a placeholder. And then 17, the number without a variable, is just 17 as its coefficient. And so this is the setup for writing the numbers for synthetic division. Those are the numbers we're going to be using as our establishment for the multiplication and the division. And then lastly, you're going to draw a line, leaving space to work. So I mean, draw a line underneath this row of numbers, but leave space to put other numbers underneath. So you should have room for 2 rows of numbers. Alright, so this is your setup. You check to see that this is in order, and if it's not in order, then put it in order. Then you're going to solve the divisor, write that number here, take all the coefficients, write them down using any zeros to represent missing pieces, and then draw a line. That's your setup. That's before we even started the synthetic division. Those are the little checks you have to mark off before we can get started. But once you're there, these steps for synthetic division are all written right here. You're going to take the first coefficient, and you're going to do nothing to it except write it directly underneath the line. So I like to draw this arrow. I physically draw an arrow like this. You just take the first number and you write it underneath the line. Then you always multiply diagonally and add straight down in the columns. So diagonally, I'm going to multiply this number by the -2, which is -2. That fills in this blank spot right here. Remember how I said there are 2 rows? You already have the first row of numbers. We're going to create the second row of numbers by multiplication. So when I multiply, I put the -2 here, and then I add down. So it's -3 times -3 plus -2. -5. Then you do it again. -5 times -2 is 10. Then you add down in the column. -11 plus 10 is -1. Then you do it again. -1 times -2 is +2. Then you add down. 0 plus 2 is 2. Then you do it again. 2 times -2 is -4. Add down 13. You do that until you get to the end of the row. That's synthetic division. Just multiplication and addition. Now, these numbers that we have here, you have to translate them into what our actual quotient will be, our answer. It's called the quotient. You guys could have a remainder, so this is what we're going to do next. Once you guys get the numbers, you're going to label what the numbers represent. The number at the end is always the remainder. Always. Could be a 0, which means you don't have a remainder, or it could be some number like this, meaning you have something left over after the division. So this is your remainder, and then you guys work from right to left. I know it's kind of in reverse of what we're used to, because we usually read from left to right. You guys want to label them going from right to left. So your next number, doing standard form in reverse, will be the number without a variable, then x squared, then x cubed. So label them from right to left. If the answer is x, what do you notice about this compared to what the dividend was? What was the highest power of the dividend? 4. And then what's the highest power of your quotient? 3. So you should notice every time you use synthetic division, your answer should be 1 degree less than where you started. Okay? Now, these numbers right here that you got as your solution to the synthetic division, those are the coefficients to your answer. So your answer would be 1x cubed negative 5x squared negative x plus 2. And then with your remainder, the way that you write a remainder is you take the actual number from the remainder and you divide that by whatever the divisor was. Okay, which was x plus 2 this season. So this would be your answer. You have this polynomial plus 13 left over. That's how you use synthetic division. Right? The only other complication you guys need to be prepared for is what if your divisor, when you solve it, instead of getting a whole number like this, you get a fraction. That's possible. Okay? If the divisor solves to become a fraction, like 1/2 or 2/3 or something like that, you're going to do synthetic division the same way. Your numbers should work out so you get whole numbers in this process. It should work out nicely like that. But when you get to the end, if your divisor was a fraction, at the end you have to divide every number except for the remainder by the denominator of the fraction. Okay, so I have an example and I'm going to show you about that. That is something that you're going to have to remember, and it's easy to forget. So make sure you guys think about that every time you guys are doing something. Okay, so go ahead and turn the page. Let's see some examples. So we're going to skip the second one here. The second one, you can't use synthetic division because the divisor has a square. You can only use synthetic division if it is a linear binomial. So you can't have powers there. So we're just going to skip number 2. You have to use long division, but we're not going to worry about that. All right, so we're going to start with example 1. Step A for the setup is to make sure that it's in standard form. Is everything in decreasing order with the biggest power first? Yes? Okay. Is anything missing? If the highest power is 3, that means you then need to have 2, 1, and then nothing. I have 3, 2, 1, nothing. So everything's there. So that's a double check. It's in order already and nothing's missing, so we're good. Next thing you want to do is take this and solve it for x. So what would the value of x be if I solve that? 3. So you're going to find that, then you're going to come over here and kind of write it off to the side. Now on the previous page I drew a little box around it. I personally like to use this instead. I like to draw, because normally when you divide, usually you draw it like this. For synthetic division I draw it upside down. So all the numbers are going to kind of be going down, dropping as I'm working with them. So I like to do this instead of drawing this way, but you guys can do whatever you want. Next, since I already know that the dividend is in standard form, nothing's missing, I'm just going to take the coefficients and write them down. So what's the first coefficient I would write? Nope. Coefficient. 6. Next. 10. So you take each of the coefficients, not the variables. You never write the variables in synthetic division, just the coefficients. Now we're ready to start. So you're going to draw an arrow and drop the first number underneath the line. Then the first operation is multiplication. So what is 6 times 3? 18. Multiply diagonally. Anytime you touch the divisor is multiplication. So 6 times 3 is 18. Then once you have a complete column, then you add. So if I add down, what do I get? 0. Then you do it again. What's 0 times 3? I have a complete column, add down. 1, do it again. 1 times 3. Full column, add down. 0. Once you've gotten to the very, very end, you have your last column filled and all of your numbers situated. Now we're going to label. What does this last number represent? The remainder. So I put an R here to represent remainder. And then from right to left, using standard form, I would have the number without a variable, then x, then x squared. Which makes sense because our dividend started as x cubed, and when you divide, it should go down by a degree, so it should be x squared now. So then to write my answer, I'm going to take each of these and write them out as a polynomial. So what would I write this term as? 6. Okay. If the coefficient of x is a 0, should I write that at all? It just means you have 0 x's. Don't write plus 0x, it just means the term isn't there. Just like if we had noticed something was missing, we would put a 0 here. But you don't have to include it in your answer. And then how would I write this as a term? There's no remainder, so you're not going to write a remainder unless you actually have a remainder. Because the remainder is 0, then you have to divide it. Okay? What's interesting about synthetic division, and we're going to see this more in next class, how we can apply this, synthetic division is another way of factoring. So we're used to factoring things that are quadratics. They have a degree of 2. We use the x trig and we factor it that way. Synthetic division can allow us to break down the function by a degree. So we're essentially factoring. If I wanted to write this in factored form, I could do that. This polynomial is the same thing as this. This is the factored form. So factoring, which is kind of, you can kind of think of factoring as a way of dividing or undoing FOIL or multiplication. Synthetic division is the same way. So we're actually going to use synthetic division to help us break down polynomials in order to help us factor and solve them. We're going to see that next class. Alright, moving on to example 3. Alright, you guys tell me, what would I do first? We don't look at coefficients first. Okay, we're going to check the entire dividend, the exponents more specifically, to make sure that it's in standard form. Is it in standard form? Everything's in order, starting with the highest and then decreasing from there. Okay. So it's in standard form, but is everything there? What's missing? What would we consider as missing from this part? The number without the variable. So what I like to do is I go over here and I take note of what I'm missing. So if it's missing like the term with the x, I would write x or the x squared or whatever. So I write down what it is that I'm missing, and then you have to remember to include a 0 when you guys are writing out the coefficients for that term. Alright, what would the solution be that I'm going to use for the divisor? As a fraction. Always use a fraction, the fraction form of the solution here when we're doing synthetic. So I'm going to use -1/2 for the scratch word part of the calculation part of this. Alright, now how do I fill out the rest of the first row? Use the coefficients, so what would they be? 4, 4, negative 9, and 0. You have to make sure you include the 0. Even though it's at the end, it's still significant that you put a 0 there to represent the number without a variable. Alright, now what do I do to start the process? Bring down, and it's really important to draw that arrow there so it blocks out that part in the column so you don't accidentally put a number there because you don't want to have your numbers offset by 1. So it's important to physically draw that arrow so you fill in that spot in the row or the column. Alright, now I'm going to take this number and multiply it times negative 1/2. So it should work out in this process, even though we have that scary fraction off to the side, whenever we do the multiplication and addition, it should end up being a round number, not a fraction anymore. Alright, so when I add down, what do I get? 2. 2 times negative 1/2? Negative 9 plus negative 1 is 10. Negative 10 times negative 1/2 is positive 5. Negative 7 plus positive 5 is negative 2. Negative 2 times negative 1/2 is 1. Add down to equals. Follow the math. Okay, now, before we get started labeling things, we have to remember that when your dividend solves to give you a fraction, we have an extra step that we have to take. That was in that little box at the bottom of the first page. Whenever this is a fraction, before you label, you're going to leave the denominator alone, leave the remainder alone, but every other number, you have to divide by the denominator. So I'm going to have to divide everything here by 2. So it's really 2, 1, negative 5, and negative 1. You don't divide the remainder, just everything before. And I know that's easy to forget, so make sure you guys are paying attention. If your dividend becomes a fraction when you solve it, chop each of these by dividing them by the denominator. Now I can label, so what does the 1 represent at the very end? The remainder. Then we have a number without a variable, then x squared, and then x cubed. And again, this should make sense because our dividend started with x to the 4, and when you divide, you should go down 1 with the dividend. So what's my final answer? Who can tell me what the final answer would be? Writing it out officially as a polynomial.
2x cubed plus 1x squared minus 5x minus 1.
Is that it? There's more. How do you write when you have a remainder? Plus 1 over 2x plus 1. Whenever you have a remainder, you're going to use the sign, the value of the number, because this is positive, that defines it as addition. So plus 1, and then you divide it by whatever the divisor expression is. You have your full answer. Okay? Alright, I'll do this number 4 with you guys, and you're going to do the bottom 2 on your own. So what's the first thing we're going to check for example 4? The terms are in order using the exponents as a guide. So are they in standard form? No. I have to switch them because the x cubed should come should come first, and then the negative 64 should come second. And then you should take note of anything that's missing. So what's missing from the standard form? So I have x cubed, but I don't have x2 or x1, and then I do have the number without a variable. So I'm missing 2 pieces of the 4. Alright, what value does the divisor give me when I solve? Okay, so I have 4. Save it up. My coefficient for x cubed is 1. And then next, technically, would be x squared, but do I have x squared? What do I put in its place? 0. So I have 0 for the x squared, 0 for the x, and then negative 64 for the number without a variable. Alright, so remember the first thing you do is drop the first number. Don't mess with it, just drop it down underneath the line. Then you can start the multiplication and addition process. So I'm going to multiply 1 times 4. 4. Add down, and I still have 4. 4 times 4 is?
16.
Add down, I get 16. 16 times 4. Add down, I get. Alright, do I have to do the whole extra division process thing? No, because this is not a fraction. Alright, so the 0 represents 16. 4. X squared. So again, it went down 1 degree. Probably dividend. So then my final answer would be x squared plus 4x plus 16. Okay? Any questions about the process so far? Alright, then I want you guys to try number 5 and number 6 on your own, and then in a few minutes I'll put the quotient on the board and you can check what you got. Alright, so these are the 2 answers that you guys should get for example 5 and 6. And it's not good.